Hey there, it's me, Bill. Welcome back to the tiny little workshop where I am sitting down so I can show off this contraption. I've made a paper model of a dust separating cyclone, and I will disassemble this, transfer the pattern to this rusty old piece of sheet metal that's been sitting outside for about 7 or 8 or 9 years now, and finally make this thing that I've been holding on to for all this time into something functional and useful. So perhaps before I get into the actual building, I should explain why in the world you want a Cyclone separator. The one I'm building is sized for my shop vac, and so it'll have a 2.5-inch inlet and a 2.5-inch outlet. But the idea behind this is that this mechanical device separates out the larger and heavier materials, your sawdust, your wood chips, that kind of stuff, and collects it in a 5-gallon bucket. How this works is, at the inlet, you can see it's angled slightly. So as the wood chips and the air and everything enters, it starts to go down and swirl inside here. There's actually an air ramp that spirals down as well. So the wood and everything spirals down through this cone, and it goes all the way down and collects in the bottom in a 5-gallon bucket in my example. This design is by a guy named Bill Pence online, and his calculator is on his website. It's linked in the description, and you can size it for whatever need you want, from a small one like this all the way up to giant, huge workshop ones. So your sawdust and everything collects in the bottom. Out the top, through the center, comes mostly just clean air. It'll still have very fine dust, but it won't have the bigger particles. This ring will fit on top, and I will size this hole and build an adapter for the 2.5-inch shop vac hosing. This goes off to the shop vac itself. So that's the gist of how this is supposed to operate. Now to get into the dirty, actual build. First off, I need to clean that big old piece of sheet metal that's all rusty. First, I had to find where I had left this particular piece of sheet metal. A bunch of vines and dead leaves were almost completely covering it, and it had been in this same area for more than 8 years, just waiting for me to come back and pick it up and find a use for it. So most people who build a Bill Pence Cyclone will use either 22 or 24 gauge sheet metal, something around there. The corroded panel that I'm using is about 1.6 millimeters thick, which would make it 16 gauge. 16 gauge is twice as thick as 24 gauge, and it is much more work to bend and form into complex shapes. So the first tool that I tried to use to clean off all the rust and scale and paint and everything was a wire brush that I chucked up into a drill. It cleared off the dirt, but it didn't spin fast enough in the drill to remove all the paint. Now it was time for the angle grinder and a 40 grit flap disc. This worked pretty well. I also made sure to do this part outside where there was plenty of ventilation and clean air. So with all of the old paint and most of the rust taken care of, I pounded a few dents out, and it was time to disassemble the paper model that I had made and use it as a template. The individual pieces were laid flat, positioned, and then repositioned to try and fit everything reasonably close together to minimize any waste. My first attempt at marking the edges and the cut lines was with a black permanent marker, and as it turns out, black does not show up on dark metal. So plan B was to use a pick as a scribe and mark the lines into the metal itself. One potential danger of doing this on the floor is that you may wind up within tongue reach of small dogs, so watch out. So the first tool I tried to use to cut this metal was a pair of straight shears that I owned, the biggest ones that I had access to. It actually sort of worked at first until I got deep enough in that I lost my initial leverage advantage, and I just couldn't make this work any further. So back to the angle grinder then. I wound up using metal cutting wheels for the rest of the project. And just going slowly at first, kind of making sure to follow the curved lines as accurately as possible. The very first complete piece that I cut out was for the cone. Now after each piece was cut out, I used the bench grinder to clean up the rough and jagged edges. Between the grinding wheel and the wire wheel, it actually goes pretty quick. I only managed to lose one cutoff wheel. This happened when the offset portion of the wheel plunged deep enough in to make contact with the metal, and then it was all over. This piece is going to be the upper cylinder. It has an angled entrance for the inlet. On some of the spots that the bench grinder couldn't quite reach, I got to use some of my hand files that I made handles for in a previous video. This particular piece is going to be the outlet. It needs to be round, just like the paper template. This pipe and a hammer are my crude forming tools. Of course, I had to try bending it by hand first, but that wasn't quite going to work. Plus, having the pipe laying on the floor presented its own challenges, being as it was unsecured and just flopping around. So I gave up on that approach. Instead, I clamped the pipe down on the edge of something solid and grabbed a nice, hefty hammer. It kind of took a while to get the hang of just where and how to hit the metal in order to make it curve the way I wanted. So with this piece all lined up and temporarily clamped together, I could tack weld the edge. On this one, I forgot to clean the rust off of one side, so it was a little finicky to weld together. I will also blame my terrible looking welds early on in this project to the fact that my first welding helmet that I was using, the auto darkening feature wasn't working like it's supposed to. There we have it, one globtacular Cyclone outlet. Next up was the dust chute. This sits on the very bottom of the assembly beneath the cone. All of the sawdust and everything funnels down through it into the 5-gallon bucket. This is a tighter bend, and the piece wasn't quite as wide as the outlet, so it actually went much faster to form. At least this time I managed to clean off the rusty, scaly outer coating and help my MIG machine out. One completed dust chute. Onto the bigger pieces. Here's the upper cylinder being formed. I used the same basic method, just bigger and with larger hammer swings. When the seam was fully welded and cooled, I folded one interior edge over using a piece of angle iron. There we have it, one upper cylinder ready to go. Now for the big bruiser. This is the cone. It is a very wide piece of metal that needed to be formed into a compound curve. It is wider at one end than it is at the other. There were some, shall we say, unorthodox methods being employed in forcing it to curve. This included hammering against the pipe, hammering on the floor, smacking on the pipe, and smacking on the floor. Also, remember to drink plenty of water when swinging a heavy hammer for an hour in a workshop with no air conditioning on the 4th of July. I laid out a bunch more booger welds with my wonky welding helmet and was just about ready to call it a day after this piece was done. Here we are, one mostly cone-shaped piece of metal. I turned on a fan, which kind of started making some wind noise in the microphone, and then after that I traced the bend lines for the only rectangular piece of this whole assembly, the inlet. I will also need to make a rectangular to round adapter to hook this up to my shop vacs hose, but that'll be in part 2 of this build. Now here's my super basic sheet metal brake-like device. The piece to be bent is clamped between 2 pieces of angle iron. I started the first bend by hand and then finished it up with a hammer. If I do this carefully enough, I can make a reasonably sharp 90-degree angle. After that, you just kind of reposition it, clamp it again, repeat, and just keep bending on and on. The last bend had to be done entirely with the hammer. Ta-da! More clamping, more welding. This time I didn't overlap any material, and instead I just kind of butt welded the seam together. Finishing up the rectangular inlet completed the first day of this build. The next day I started out by tracing the shape of the air ramp. In other parlance, this is known as a screw flight. Now, one big challenge with trying to form a helix from a flat piece of material is that it won't really form properly without some very careful tweaking. I made the decision to just keep using the angle grinder for this, even though this shape has a tighter radius than any of the other things that I had yet cut out. Once again, slow and steady was the order of the day. I didn't want to mess any of this up. After a little cleanup, it actually looked worryingly loose when I slid it over the outlet. I did do some research beforehand into how screw flights are usually formed, and I decided to try the basic bend it little by little all the way down sort of approach. Then I tugged the ends in opposite directions. Voila! It's not perfect, but I am still completely in awe that I somehow made this look so easy on my first try. Here we have the air ramp and outlet being test fit inside of the upper cylinder. Now this made me realize that I perhaps had made the inlet too wide in one direction. It would need to be trimmed for clearance. So I tack welded the air ramp in place, and I was making a few more adjustments to the inlet when I heard some loud fireworks just outside the workshop. I walked outside, and this is what was happening. Some neighbor kids had managed to light the next yard over on fire, so I was outside helping with containment that night. We lost power for about 10 hours. This, of course, stretched the build into a third day. So when I last left off, my neighbor's yard was on fire. That's another video, it's up on the channel, but it was started by fireworks and some kids. At the moment the fire started, I was modifying the inlet to better fit here, and I'm just kind of test fitting everything together. I've got the air ramp and the outlet inside the cylinder here. Once I have everything working like it's supposed to, I will weld all around the outside edge of the air ramp itself, and then I will add the inlet, and we can start combining the rest of the pieces together and then build the cap that goes on the top here. So this shows all the last little bits of trimming, bending, and tweaking that I had to do to get all 4 of these individual pieces to line up just so. The clamps on the bottom are keeping the outlet straight until it's welded into place. Once it was tacked in, I could pull off the clamps and slowly stitch everything together. I actually wound up pulling the inlet one last time so that I could reposition it just a little bit higher. Weld, weld, weld. Lots of welding. I wanted this screw flight itself to be pretty well airtight so that all of the incoming dust would spiral down, and the only thing being pulled up and out was clean air. After a last little bit of cleanup with a file that I found at a storage unit sale and a handle that I made myself, the inlet was ready to be welded in place. You can see how it's a nice straight shot into the air ramp, no overhangs on the top or bottom. Here's the air ramp, fully welded all the way around. This imposing stack would soon be one piece. I kind of liked the brutal, raw, overbuilt, post-apocalyptic junk feel that it was starting to give off. Tacked together. A good idea with any welding project is to not do too much in any one spot. The metal will get so hot that it will warp. Instead, you're supposed to work your way around, letting things cool down before you come back to hit them again. Just a little cleanup with the 40 grit flat disc. Now here's the dust chute going on. I needed some kind of a top cap, and I happen to have some old worn out saw blades hanging on the wall that are otherwise worthless to humanity. Well, what do you know? Perfect fit. Now that should help with the Mad Max vibe here. I happen to have a hole saw that was close enough to 2.5 inches, so I decided to use it to enlarge the top opening. With liberal application of some water displacing oil, I eventually cut through to the other side. I reused the template from the dust chute, but I made sure to extend the length to deal with the 2.5 inch wet dry vac hose. Once again, cleaning up with the bench grinder and the wire wheel. Back to the tube where I was able to bend some of this piece by hand. Just double checking the fitment on the hose. It was ready to be welded to the suspiciously unsafe looking top cap. There we are. Hose still fits just like I intended. I flipped everything upside down to weld the top cap to the upper cylinder. Once again, being careful not to heat soak any one spot and warp any of the parts. It was now time to find a way to attach this weird monstrosity to a 5-gallon bucket. First, I measured the lid of the bucket. Then I marked out a square-ish piece of metal. I positioned it so that the weight would be evenly distributed on the bucket lid, and then I scribed where the center position was. Here we are back at the drill press with a smaller hole saw. Quick cleanup with a flat disc. A little careful alignment and then some welding. I used the same hole saw and handheld drill to open up the bucket lid. It was still very sharp even after having cut through the metal. Okay, now I had to attach the two together. I marked the first alignment hole and put a screw in place to help hold things together. Since most of my assorted nuts and bolts aren't yet in the workshop, I went with salvaged sheet metal screws instead. I happen to have some caulking laying around from another project, so I spread it on real thick. Here we go, just line up the lid and install the screws. Just about ready for the moment of truth here. Will it cyclone? Will it separate? Well, it sucked in all the wood chips that I picked up from the jointer. Time to see if anything wound up in the bucket. Hey look, a bunch of wood chips. Haha, great success. So here's where I'm probably going to leave off for today. As you saw, this crazy mixed up thing actually works. I formed it myself out of metal that is way too thick, spent way too much time welding it all together, but I made a functional thing, and I am always very excited about stuff like that. As you saw, sawdust went in, it spiraled, it fell down into the bottom in the bucket, out the top came the clean air, goes back into the shop vac. It's exactly what it's supposed to do. I still have a few more minor things to do with this, but for today, this is day 3 of this build. I am done. I am going to clean up and go to a car show. I do have just one last comment about making something as complicated as this, especially like me, where you've never seen one in person. It never hurts to make a model. I wound up making 2, the tiny paper model you just saw, this full-size paper mock-up, and then I was able to use the full-size paper one as a template for the real thing. This way I knew beforehand how all of these different pieces were supposed to fit, and I could visualize exactly how this was going to come together. So happy building. I'll see you next time.